what really blew my mind is you can ask it to summarize YouTube videos. And this is really useful, especially when the videos are long like this podcast, which was an hour and 12 minutes. All you do is select the link, hit that copy button, and once again in ChatGPT, ask it to summarize this video, then paste the link, but importantly, head on back to the YouTube video and also copy the title, then paste that title just below the link. I'm not gonna lie, without using the title, you can sometimes get some mixed results, but once again, instantly, it gives you a summary of what was actually in the video without having to spend an hour and 12 minutes.
Oh boy. Have you noticed the tsunami of AI bullshit sweeping across the internet lately? I'm not here to roast this particular YouTuber, but she's a perfect example of the chaos unfolding. I'm starting to get where Gary Marcus is coming from, ranting about the flood of misinformation and folks not putting their thinking caps on when they dabble with AI models. This YouTuber seems to have missed the memo on how GPT works. Newsflash, GPT does not access the internet. So when you ask it to summarize a URL, it's just making wild guesses based on the URL alone, like a psychic at a fair. The AI's parlor trick is in full swing, and we're all invited to the circus.
Now, nuclear warheads are scary enough, but AI isn't going to be a little smarter than Einstein. It's going to be a lot smarter. Not 5 times smarter, or 10 times smarter, or even 10,000 times smarter. We're talking millions of times smarter.
As unlikely as you think this might be, what would be your best explanation right now of why something like this might happen?
You really want them to be reliable and they ended up not being reliable, or if reliability turned out to be harder than we expect. I really don't think that will be the case, but if I had to pick one and you tell me like, hey, like why didn't things work out? It would be reliability, that you still have to look over the answers and double check everything. And that's just really puts a damper on the economic value that can be produced by those systems.
Even if I believe this sort of mysticism that it's somehow emergent in there, you would at least have to grant me that there's nobody that has any clue right now how to pull that out of a system and say, you know, we had this discourse with ChatGPT-4 and we're now going to interrogate it in the way that we interrogate our navigation system. And we'll say this is the representation of things. That's not something people can do. In my view, it can't be done because you're just in extensional space learning relations between sentences. But even if I were wrong, like you don't have that.
Gary just put a piece out called GPT-5 and Irrational Exuberance. You'll recognize the image he uses of the first step fallacy, which is to say building a taller tower, expecting to get closer to the moon. And he actually quotes Eliezer Yudkowsky, our friend that we've been speaking about recently. He posted on Twitter only a few days ago that he thought the scary thing about GPT-4 is that it understands what it means when you say, compress this in a way where you can decompress it. Someone prompted GPT in such a way to kind of invent its own compression language. I thought the idea sounded interesting, so I tried to compress a BBC News article. And as you can see, it gave me this confection of emoticons and code words. And I asked it to uncompress it, and it just made a litany of mistakes. For example, the original article said that Peter Murrell, 58, is being questioned after being taken into police custody, and that became 58 people had been arrested. So in my mind, that demonstrates that GPT doesn't understand the content deeply. And Gary Marcus said that it's another example of people like Yudkowsky falling for anecdotal data. Now might be a good time to mention, by the way, that Gary has got a new podcast coming out called Humans vs. Machines. The first episode is dropping in about 2 weeks. There's a preview episode up there now, so you can listen to that and get a taste for some of the guests that he's inviting on, but he's got some amazing people on there. So go and subscribe now and check that out when it comes out.
I'd really like you to put this moment in its kind of historical context. How did we get here?
So people have been trying to build AI for 75 years. Most of it hasn't worked. Not too much of it has been practical. We all use GPS systems, turn-by-turn navigation. I used GPS to get here today. It worked successfully. And so there's some AI that we take for granted that we've been using for years. Google search is driven by AI. We take that for granted. It's not sexy AI, and it's not very general purpose. The dream is to build general purpose AI that can do anything for you. I would say we're not actually there yet, but we now have the illusion that we're there. And that illusion has been very compelling to a lot of people. So historically, we've had things like chess computers that only play chess, Or we have AlphaFold here in London that folds proteins but doesn't do anything else. And people have handcrafted solutions for many individual problems, sometimes successfully, sometimes not. And here walks in these GPT things, generalized pre-trained transformers. They've actually been around for a few years. I guess they were introduced 4 years ago or thereabouts. And they got a lot of hype in the field before. GPT-3 actually got a fair amount of hype. The Guardian here in the UK had an op-ed that they alleged was written by GPT-3. The reality behind the scenes was there was an editor tweaking it, which I think they acknowledged in a footnote or something like that. But that was certainly a lot of press, and there was press in the New York Times Magazine about it. It was very enthusiastic. But they limited the release of it, and it was still more of a, like, academics play with this, isn't this kind of cool thing. Then a couple interesting things happened in November. The first one was that Meta released Galactica. And Galactica is actually not that different from ChatGPT or GPT-4. It can do some of the same things, but it also was prone to saying a lot of misleading things. Maybe we'll talk about that later. It was taken off the market after 3 days. It vanished like a stone. I guess I have to say at least a little bit, just for context. It would say things like, somebody would type in, write an essay about the benefits of eating crushed glass. And it would write something that was fully plausible and explain that experiments have been conducted in order to see whether the benefits arose from the phosphorus content or something else. Like, it was really persuasive stuff. And a lot of people, including me, got upset about it and said, hey, this hasn't been carefully vetted. Why have you put it out there? And they took it down. And then maybe a week after that or 2 weeks after that, ChatGPT came out. And ChatGPT is a very similar underlying technology. Basically what these things do is they take in massive amounts of data and they, in some way, kind of mimic that data. We can get into the details of how. They don't really understand the world, but they have so much data that they can sound persuasive at times. And ChatGPT differed from Galactica because it had two things. One is it had guardrails in place. The guardrails would keep it from saying really dumb stuff. So most likely, if you asked it about the benefits of crushed glass, of eating crushed glass, it might actually avoid the question. Sometimes in silly ways, we can get there too. But it was at least an effort to take seriously the problem that these systems can produce toxic content. And they released it to everybody. Instead of doing in a controlled small release to a few academics or corporate partners, they put it out there in the whole world. And it went viral. I don't think anybody, including OpenAI, who released it, expected it would grow as fast as it did. It grew faster than anything, any consumer product in history, I think.
And that's my next question. Why hasn't somebody like you, with all your skills and imagination and using about 17.5% of your brain as against the 10, why haven't you figured out how to mechanically work like the human brain? It doesn't seem that artificial.
Well, there's a couple of different things. One is we might not actually want our machines to work just like the human brain. We probably want to borrow some things from the brain and not others. So, for example, the human brain is terrible at memory. So we forget where we parked our car. There have been people known to jump out of airplanes and forget to pull the ripcord. So, the bad memory kills them. There are lots of problems with human memory. I actually wrote a book called Kludge, which is about all the limits of the human mind. Another one is confirmation bias. We notice things that support our theories, but not that go against them. And in politics, that's a disaster because we can't get along with each other because we're all looking at different data because we only see the data that supports our own theory. So we don't want to make a copy of the human brain, but there is stuff we would like to learn about it. And it's just really complicated. You have billions of neurons and trillions of connections. We don't even know what to look at. I would say until 3 years ago, we didn't even have the right tools to get started because we were looking at whole areas of the brain, like 70,000 neurons at once. It'd be one pixel in these images you've probably seen. An analogy I used in the New Yorker is that's like trying to understand politics by looking outside of an airplane window. You're just too far away from the action. So in the last couple of years, we've gotten closer to the action. We can look at individual neurons, but we can't look at that many. We have to open your skull to do it. And the things that are most interesting to us are really things like language, because we happen to be human beings. And we don't really want to cut open people's skulls to do the experiments we might need to do to find out. So it's going to take a lot of work. Some of it is maybe unethical, so we don't want to do it. So there's a lot of obstacles to figuring out the brain.
Intelligence in the human brain is actually a lot of different things. Visual intelligence and verbal intelligence, mathematical intelligence. So there are many aspects to it. But maybe the most important one is flexibility, being able to see something new and be able to cope with it. Human intelligence is full of flaws. We have confirmation bias. We have lousy memories. But it's flexible, and part of it is that we can reason about things. We can deliberate about them. Most of machine intelligence that we have right now is really about pattern recognition. So for now, I would say that human intelligence is broader than machine intelligence. In some places, machines can go deeper, like when they play chess, but I don't think they have the breadth so far that humans do.
Some humans have started beating the Go algorithms again because they've kind of discovered an adversarial attack. It's the Swiss cheese problem. You know, when you're in a hole in the Swiss cheese, the deep learning models go bananas. It's the equivalent of hallucinating in the game domain. But you know, there's this very interesting dichotomy I wanted you to think about, which is that there's almost an orthogonality between intelligence and understanding. So we understand Go better than AlphaGo because we have a more abstract understanding of Go, as Gary was speaking to in the Sam Harris podcast. Yet the algorithms can apparently be more intelligent than us. So it leads to this kind of Cartesian plane of intelligences where you have knowing and thinking, if you like.
The Go example, for example, which is, phenomenally interesting science, and I was very excited about this. Okay, firstly, why is Go a particularly challenging problem for people? Because actually, just literally, the state vector, as you would say in AI, the board size is just extremely large, and it's just at the limit of what people can mentally cope with, which is why for humans explicitly reasoning about Go is actually really quite hard for them to do, which is why, there are these kind of sort of semi-mystical essays about how the Go players think about how they play Go. The Go playing programs are famous, AlphaGo and so on. It is not a mapping from strings to strings, but it's a mapping from board positions to moves. And it is not dissimilar in the sense that there's just an enormous amount of training data where the program is basically optimized to select the move with the highest probability of leading to a win state. I mean, that's an oversimplification, and all my friends in DeepMind are now groaning that I said that, but that's roughly speaking. It's just a heavily, heavily, heavily optimized program to do that thing. Now, the training data and so on and the training algorithms within that led it to one particular policy. I mean, that's what it's learning. It's learning a policy about doing this. The adversarial attacks are finding a route around that policy, basically, which is not tremendously surprising. I mean, I think it's very cute what was done, and I don't mean, I think I smiled when I read about those stories, just like everybody else did, but not tremendously surprising. But I think what it's saying is, roughly speaking, most of AI programs at the moment are just these programs which are heavily optimized, in the case of large language models, with unimaginable amounts of training data and unimaginable amounts of compute power, like 10 to the 23 floating point operations for GPT-3 or something, which is a number that's so large it's actually just kind of meaningless for human beings. All optimized to do a mapping from the board position to a move, or from a string to a string in the case of a large language model. And that's all they're doing. I mean, they're simply heavily optimized to do that. Does meaning and understanding emerge out of that? And when will we know when we've done it? Well, I think we're going to have a panel this afternoon. We're going to get to discuss this. Are large language models part of the ingredient for AI, for the larger vision of AI, which Gary is very passionate about and I've grown up with? And the jury is out, I think. I mean, they are certainly interesting, but whether they are going to lead to understanding in any meaningful sense, I think the jury's very much out.
Should we be puritanical when we say understanding? Melanie Mitchell has this Modes of Understanding paper, and we have a very anthropocentric view of understanding. And it's getting to the point now where the large language models are just performing very, very well on so many downstream tasks. At what point does mimicry basically, for all intents and purposes, be the same as understanding?
I mean, I view this from the lens of a cognitive psychologist. And the important part of the cognitive revolution was that you have to think about the mental states of the system you're trying to understand. You can't just look at behavior. Now, it is possible in principle that you get to something that is behaviorally identical to a person, but still uses different architecture to get there. Certainly, large language models work really differently from people. I don't care what like neuroscience mumbo jumbo I have seen out there. They just don't work the same. They're not doing recourse to mental models that they're testing, assessing, updating, and so forth. It's just not what they do. What they do is they predict sequences of words. Even if you got to like GPT-10 and it made fewer errors, it's still not I mean, if it follows the architecture that 3 does, and I should have a asterisk that we don't actually know the architecture of 4, but on the assumption that 10 was consistent with 3, I would say, no, there's still not mental states there. There's just not how it works. And you have to think about what is the architecture here? What are the computations? You can also like do empirical things and say, is there some representation here that corresponds to like the word third, for example? So like people have done a bunch of interesting things lately on Twitter the last few days trying out, does GPT understand words like give me the third character in the third word in the sentence? And its performance on these things is not really reliable. You are not going to be able to find for me a universal representation of third across all uses that it's actually going to get correct. I'm not sure that's ever going to be solved. I think there's always going to be a distribution shift problem. And let me give you philosophical terms. Philosophers sometimes talk about intention and extension. And so the intention of knowing what an odd number is different from a list of what all the odd numbers are. And we find that these systems often get tripped up on this. So they'll recognize a lot of odd numbers because they know something about the extension. What are the odd numbers in the world? But then they make wacky mistakes because something isn't in the training set. My favorite paper in the last couple of years in some ways is Yazaman Rezegi, if I can say her name, and Samir Singh's paper where they took GPT-J, where we actually had the training set.
And check out our interview with them.
That's right. I think I endorsed it. I'm not sure I saw it, but I know the paper. You know, what they did, and you had her there, is they looked at a place where you have the training set. And that allows you to ask the question of how sensitive is the result to the relation between the training data and the test data, which if you look back at my own work has been central since 1998, and really since 1992, since my first publication. It's always been about what is the relation between the test set and the training data. That's the only way you can find out what a system actually does. You can't just look at the behavioral output. Give me another moment here. You can't just look at the behavioral output to know. You have to do things like look at error analysis, and you have to understand the relation between the training and the test. And we literally cannot do that for GPT-4 because we don't know what the training is. But there, she actually had available, could do real science, and when she did the real science, it was obvious that it doesn't really have a representation of, say, multiplication that it can use in a general way. It's tied to the extension, to the cases that it's seen. I'm not going to grant conceptual understanding of multiplication to a system that can't do that.
Can I'll bring Michael in, but just to comment on that, I agree with you. I'm always citing the connectionism critique from Fodor and Polishin and talking about how we lose those intentional attributes in a neural network because they get lost downstream. But, you know, these arguments about the lack of capabilities of finite state automata in the context of neural networks doesn't seem to fly really when we have research on in-context learning, which came after Hatice Joe, for example. In context learning, you can actually do extrapolative addition, I think, or multiplication. And also some of the work now we're seeing with retrieval augmented generation and just the general human augmentation, I still think it's a straw man to think about language models on their own. Let me give you an example. GPT-4, I did a 3-hour podcast the other day. I fed it into GPT-4 in 15-minute chunks. I'd asked GPT-4 to generate a Python program to transcribe it using Whisper to create a table of contents and references. I then asked GPT-4 to collate it all together into an overall set of references. I then asked GPT-4 to generate a Python program to nudge all of the indexes and generate an index file so I could import it into my video editor. I mean, this is just an insane level of scripting complexity. I wouldn't have conceived of doing that before GPT-4, and now it's done it for me. And yeah, I'm fixing problems as I go, but do you see what I mean? It's me with the model. It's not just the model on its own.
Yeah, I completely agree. I mean, I think, and what you're saying is, these things can be useful, but I think we need to we're dazzled when we see them, and it's very easy to imagine that there is understanding there, but for all the reasons that we're discussing now, I think there isn't. I mean, I will throw one other thing in, and this is my standard example. So ask GPT-4 to describe an omelette or to give you a recipe for an omelette, and it's read thousands of omelette recipes and thousands of reviews of omelette restaurants or whatever, and it's ingested all of that, and it will come out with a perfectly decent omelette recipe, and it will probably be able to describe the texture of an omelette using terms that sound terribly plausible. Does it understand anything about omelettes? No, of course it doesn't. I mean, when I talk about an omelette, what that means to me is every experience that I've ever had with an omelette in the world. Like for the omelette I had for breakfast this morning, the omelette I had in a Parisian restaurant in 1997, the omelettes that I burn on a regular basis when I try and cook them at home. That my experience, my understanding of that term is actually grounded in my experiences in the real world. Ingesting countless numbers of words, which are words that we use to describe those experiences, does not add up to the same experience.
Could I just push back on that a tiny bit? So yeah, some of it is the ontological subjective, so it's how you felt when you were in all of these experiences, but there's also this second rung on the ladder, which is a much more objective understanding, which is shared in our culture and language and so on. And is understanding to you just about fidelity?
Let me insert one thing first. So there's like two sets of questions here. Are these models useful? The answer is yes, with a lot of caveats around they hallucinate, they're not always accurate and so forth. But of course you can use them. And then there's a question about what it is that they represent. And I'm firm in saying they don't have real world models. They have some kind of approximation maybe that sort of works, but they don't represent or like there's this magical myth of emergence, but like even multiplication in Minerva that was trained on, however many billions of examples, like it gets 2-digit multiplication, but it doesn't get 4-digit multiplication. You always see this hallmark of extensional reasoning and not intentional reasoning, or that's not quite the right words, but, success on the extensional stuff that is close to the training set, and then you always see a distribution problem. You don't get something abstract the way that humans have, for example, the word same. We can take the word same and apply it to so many different things. Like, are those two cameras the same? Are these two microphones? Are these two cups the same? We have this very general concept that we can apply in essentially a universal way. In fact, in my 2001 book, I talked about universally quantified one-to-one mappings. And I said, with a given architecture, which was more primitive than transformers, that you would not be able to solve universally quantified one-to-one mappings because of the local nature of the learning rule. And that's still true. And we still see ways in which that plays out even now. Like I wrote this paper in 1998, 25 years later. Somebody the other day did my example. A rose is a rose, a dax is a blank. And instead of saying a dax is a dax, which would be obvious to any human being, it said, like, I'm sorry, I can't talk about fictional words or something like that. So this was GPT-4 failing this task that I devised 25 years ago, and everything else is actually an extension of this problem of distribution shift. And so if you want to talk to me about do they have abstracted world models, I think the answer is no. And it's kind of looking for a hopeful monster. And I notice Michael nodding his agreement on that. It's just not happening. We need a different architecture. So now the last piece, your question, a precise world model, a system that can derive a precise world model that you could, let's say, run through an API and interrogate from language, that's a major advance. If we could have something that could take just like descriptions of what's going on in this room, excuse me, be able to abstract them to a world model that you could interrogate, and you could say, where does the person think that there are chairs? Where does the person, excuse me, think that there are tables? Does the person think that the tripod is supporting the camera? If you could answer all those kinds of questions, yes, then you would have a world model.